Welcome to my channel Arun Kumar at Exam Guru. This video will be dealing with the topics related to mechanics of solids. There will be 5 multiple choice questions on force and stress. Question 1. Axial force always act. Option A. Along the axis of a body. Option B. Perpendicular to the axis of a body. Option C. Parallel to the cross section of a body. Option D. Perpendicular to the cross section of a body. Let's look at the basics of force. Force is classified into 3 categories: longitudinal force, shear force, and twisting force or torque. Longitudinal force is further classified into axial or normal force and eccentric force. What's the difference between cross section and transverse sections? These are the two terms frequently used. So cross section generally refers to sections formed by planes cutting at any angle within an object. If you look at the cylinder shown in the figure, there is a cutting plane cutting at a suitable angle. The cutting plane divides the cylinder into 2 parts and the cross section is shown in one of the parts. Now what is transverse section? It refers to sections formed by planes cutting at right angles to the length. You can see in the figure shown, the cutting plane is at right angle to the length, and the cutting plane divides the cylinder into 2 parts, and the transverse section is shown in one of the parts. In mechanics of solids, both cross sections and transverse sections are considered to be the same. Now let's look at the longitudinal force. You can see in the figure a cylinder is shown, the length and end cross sections are marked. The longitudinal force always acts on the end cross sections parallel to the length of a member. The longitudinal force is marked in the figure, and it always acts perpendicular to the cross section of a member. You can see the angle between the force and the cross section is 90 degrees. Let's look at the definition of axis. Axis is an imaginary line passing through the centroid of end cross section and parallel to the length of the body, and it is located inside the body. So the centroid of end cross section is shown, and the axis is marked connecting the centroid of both the end cross sections. So axis is perpendicular to the cross section of a body. What is normal force or axial force? It's a type of longitudinal force, always act along the axis, and it can be tensile or compressive. So in the cylinder shown in the figure, the axis and the centroid of end cross section is marked, and the tensile force which points away from the cross section is shown in the figure. So in the tensile force, the point of direction of force is away from the cross section, so it is clearly shown in the figure. Now when it is compressive, the compressive force points towards the cross section. You can see in the figure, the compressive force is marked. Now what happens when normal force or axial force act as tensile force? So in a cylinder there will be an increase in length. It is similar to stretching a rubber band. You can see in the figure, a rubber band, when it is allowed to stretch, there will be an increase in length of the rubber band. What happens when normal force or axial force act as compressive force? You can see the compressive force points towards the cross section. There will be a decrease in length, just opposite to that of the tensile force. Let's look at eccentric force, which is another type of longitudinal force. A cylinder is shown with centroid and axis. is a type of longitudinal force that acts at a distance away from the axis of a member. So eccentric compressive force is shown in the figure. So compressive force always points towards the cross section, and the line of application of force is shown. The distance between the point of application of force from the axis of the member is known as eccentricity E. So eccentricity E is shown in the figure. To make clear distinction between normal force and eccentric force, three cylinders are shown. The leftmost cylinder is the case of a normal or axial force, where the force passes through the axis of the cylinder. In the middle cylinder, the eccentric compressive force is shown, and in the rightmost cylinder, the eccentric tensile force is shown. The tensile force points away from the cross section, and the compressive force points towards the cross section. So in the eccentric compressive force and the eccentric tensile force, the line of action of force is away from the axis. The another category of force is shear force. So the shear force is marked in the cylinder shown in the figure. So the shear force generally acts perpendicular to the axis. So the angle between the axis and the shear force is 90 degrees, and it generally acts parallel or tangential to the cross section. So the cross section is shown and the shear force acts parallel to that. Now what's the effect produced by shear force? The shear force causes angular deformation. So the angular deformation is shown in the figure. The third category of force is twisting force or torque. The force that causes one end of the member to twist relative to the other end. It is twisting force or torque. Moments are applied in opposite direction at the ends or cross sections. As you can see in the figure, the end cross sections, the moments are applied in opposite directions. Now there will be a relative rotation of cross section in the case of twisting force or torque. Now what's the difference between rotation and twisting? Two cylinders are shown. Both the cylinders have a rectangular blue colored strip. Now in the rightmost cylinder, rotation occurs, and in the leftmost cylinder, twisting or torque occurs. Moments are applied in opposite direction in the case of twisting or torque, and applied in the same direction in the case of rotation. So if you look at the left cylinder where torque is applied, the end cross sections has relative rotation, that is, one cross section rotates more than the other. And if you look at the right cylinder where rotation occurs, you can see that the end cross sections rotates throughout in equal magnitude and same direction. So what's the difference between torsion and torque? In mechanics of solids, the twisting force is known as torque or twisting, and the effect produced by torque, that is relative rotation of cross section, is called torsion. So question 1, axial force always act. So the right answer to the question is option A, along the axis of a body. So the figure is shown where the axial force passing through the axis of a body. Now if you look at option B and option C, both refers to the shear force. So option B is perpendicular to the axis of a body, and option C parallel to the cross section of a body. Both are the cases of the shear force as shown in the figure. And option D, perpendicular to the cross section of a body, it can be a case of longitudinal eccentric force as shown in the figure. So the right answer for question 1 is option A. Question 2, twisting force produces. Option A, axial stress. Option B, longitudinal stress. Option C, shear stress. Option D, bending stress. If you look at the cylinder, where axial tensile force act, where the direction of force points away from the axis. To understand the concept of stress, let's take an inside cross section and we question what will happen at this inside cross section due to tensile load. Let us separate the cylinder at this inside cross section and find it out. So what we obtain is tensile stress when we separate the cylinder at the cross section. So what is stress? Stress is a group of force vectors acting over a particular cross-sectional area when an external force is applied. So you can see in this figure, there are a group of force vectors that are acting away from the cross-section because it is tensile stress. The another definition of stress is the resistance to deformation caused by external force. What happens when a axial compressive force acts? And when we divide an inside cross section, compressive stress occurs. So compressive stress points towards the cross section. When shear force acts on a cylinder, initially shear deformation occurs, and at the inside cross section, shear stress occurs. We have looked into the classification of force. Now what does each type of force produces? The axial or normal force produces axial stress, eccentric force produces axial and bending stress. Bending stress I will be dealing in the next video. The shear force produces shear stress and twisting force produces shear stress. So we should note that shear force and twisting force both produces shear stress. Now what's the formula for finding axial stress? It is axial force or longitudinal force by cross-sectional area. Now formula for finding shear stress due to shear force only and not torsional force, it is shear force by cross-sectional area. I have mentioned shear stress occurs both by shear force and torsional force, but the formula for finding shear stress due to shear force is shear force by cross-sectional area. The unit of stress is Newton per mm square or pascals, and 1 megapascal equals 10 raised to 6 pascals or 1 Newton per mm square. So question 2, twisting force produces. So the right answer is option C, shear stress. Question 3, Poisson's ratio is the ratio of option A, lateral stress to longitudinal stress, option B, lateral strain to longitudinal strain, option C, stress to strain, option D, strain to stress. So what is strain? Strain is the ratio of change in dimension to original dimension. Strain is classified into two types, linear strain and lateral strain. So what happens when axial compressive force acts on a cylinder? The outline of original cylinder is marked in blue color. So when the axial compressive force is applied, there is decrease in the length with respect to that of the original cylinder. So it's shown in the figure, the decrease in the length, and also there is increase in cross section with respect to that of original cylinder. So the increase in cross section is also marked in the figure. It is similar to compressing a balloon. When a balloon is compressed by our hands, and when we compare it with the original balloon, the compressed balloon has an increase in horizontal dimension and decrease in vertical dimension. Same way, when axial tensile force acts, the effect produced is opposite to that of the axial compressive force. That is, when the axial tensile force is applied, there is increase in the length with respect to the length of original cylinder. So in the figure, the outline of original cylinder is shown in blue color. The increase in length and also the reduction in cross section with respect to that of original cylinder, that is also shown in the figure. Hence, there is a change in dimension both along the axial direction and the cross section when axial load is applied. Linear strain measures the change in dimension along the axial direction, that is, change in length to original length. Lateral strain measures the change in dimension along the cross section, that is, change in cross sectional diameter to original cross sectional diameter. So linear strain equals to delta L by L, lateral strain equal to delta D by D. Poisson's ratio is the ratio of lateral strain to longitudinal strain. The least value of Poisson's ratio is -1 and the maximum value is 0.5. The value of Poisson's ratio for various materials is given below. Cork 0, rubber 0.5, steel 0.3, concrete 0.1 to 0.2. Question 3, Poisson's ratio is the ratio. So the right answer is option B, lateral strain to longitudinal strain. Now question 4, modulus of elasticity is the ratio of option A, lateral stress to longitudinal stress, option B, lateral strain to longitudinal strain, option C, stress to strain, and option D, strain to stress. According to Hooke's law, for a material, stress is proportional to strain up to the proportionality limit or elastic limit. If you draw the stress strain curve of a material, curve will be a straight line up to proportionality limit. Now stress is proportional to strain according to Hooke's law. Removing proportionality, you get stress equals a constant into strain, and the constant will be equal to stress by strain, and that is modulus of elasticity. Modulus of elasticity is a constant for any material and it's a measure of stiffness of a material. Higher the value of modulus of elasticity of a material, greater will be its stiffness and strength. If you look at the graph of stress strain curve, the slope of the stress strain curve theta gives the modulus of elasticity of a material. So in the figure, tan theta equals modulus of elasticity of that material. If we consider a stress strain curve of two materials represented as material 1 and material 2, material 2 has the slope theta 2 and material 1 has the slope theta 1. Since theta 2 greater than theta 1, we can modulus of elasticity of material 2 is greater than material 1. So we can infer that material 2 is stiffer than material 1. The unit of modulus of elasticity is same as that of stress, that is Newton per mm square or pascals. The value of modulus of elasticity of different materials is diamond 1210 gigapascal, mild steel 210 gigapascal, copper 120 gigapascal, concrete 30 to 50 gigapascal, aluminum 70 gigapascal. So question 4, modulus of elasticity is the ratio. So the right answer is option C, stress to strain. Question 5, which of the following materials possess maximum stiffness? Option A, mild steel, option B, copper, option C, aluminum, option D, concrete. So the right answer is option A, mild steel, because the modulus of elasticity is maximum for mild steel. I have mentioned before, for mild steel it is 210 gigapascal, and for other materials given in the option the value is lesser than that. When a man says, I'm a mentally strong person so I can handle a lot of stress, similarly the diamond says, my modulus of elasticity is higher so I'm very strong and stiff and can handle a lot of stress. I have mentioned before, the modulus of elasticity of diamond is 1210 gigapascal, so it is having a very high value of modulus of elasticity. If the value of modulus of elasticity of a material is high, the greater amount of stress can be generated within the body without any deformation, that is, without any strain. We know that modulus of elasticity equals stress by strain, so greater the value of modulus of elasticity, lesser will be the value of strain. So thank you. Like, share and subscribe my channel and press the bell icon to receive more updates.